Hi everybody, thanks for watching my talk on Dedicated User Environment, or DO, creating build environments for Debian and pretty much everything else. I always like to start my talk with a summary just so everyone knows where I'm going. So in this talk we'll have a project introduction describing it. I make the case for why we should be using another build tool. I provide a little bit of background on Docker because DO is a front end for that. I provide some examples of problem build cases you might have encountered and how DO can be used to resolve them. I'll do a demonstration, which is building a Debian package for a different distribution than the one I'm currently building from. I'll have a little discussion on how DO can be used to build firmware. And in conclusion, DO has solved a bunch of problems for me, and I think it can do the same for you. A little bit of project history here. I'm Alex Doyle. I am a build tools engineer who works on Cumulus Linux, which is a Debian derivative that currently ships versions based off of Debian 8 Jessie and Debian 10 Buster. So you can see where I'd have an interest in building Debian packages for different releases. I also work on the Open Network Install environment, ONIE, which is an open source firmware project for network switches that allows users to install network operating systems of their choice. This becomes relevant a little bit later on. And DO came out of work I was already doing to support different releases. Cumulus, which was recently acquired by Nvidia, let me open source this because they saw the value in making this sort of a tool publicly available. It's had a lot of beta testing, and if you ever need beta testers, what you got to do is tell your coworkers, I really shouldn't let you use this, and it works great. I've been working on getting DO into Debian. I've been working with Debian developer Geert Stappers to make it part of Debian. I hope I pronounced his name right because he has been excellent and incredibly helpful and professional in the whole process. And as for the name, why Dedicated User Environment? Well, it builds purpose-built container environments, so it's kind of descriptive for there. DO is quick to type, and it wasn't already in use by anything else in Linux that I could find, probably because all the clever names had been taken. Yes, I'm looking at you, Whale Builder. I'm just jealous I didn't think of that first. And it is open source, so I've got the URL there, and it'll show up a couple more times in my talk. So why do we need another build tool? And this is not going to be a replacement for existing build tools, but it's really more of a way to get the pre-configured build environment that you need for whatever you happen to be building. Let's look at some cases here, getting progressively worse left to right. If you're building a package for your current Debian distribution, and it's already Debianized, then you're set. You just use apt to build it. If you need to build for a different Debian release, that gets a little more complicated. If you need to build for a package that is not Debianized, then you have to run make and configure, and maybe that works out and maybe it doesn't. It doesn't always go as smoothly as it does when you're using apt. And at the end of it, what if you have to build something for a totally different target that is not at all Debianized? That becomes way more complicated. But yet all of these things have the same steps. You have to set up a build environment, and then you have to build for your target. So why is this difficult? And I think that's the second question to ask. Why is it hard? No, the real question is, why is building for Debian easy? And the answer is because Debian tools make it as easy as it possibly could be to build anything. Your environmental setup is handled by apt, because the author who wants you to build their code put build dependencies in it with a package. Build is handled by the dpackage tools because the author set up a rules file as a starting point, and thus the user doesn't have to care because this just builds with the same set of steps for everything. 3 steps: get your source and install your dependencies, and you build. You're done. Why is everything else hard? Because while it has these same steps, it's still the user's problem to get an environment to build in and configure it to build. What would be nice here is a tool that lets the user create an environment that's already configured to build the software for whatever that operating system is. And the first solution that most developers come up with when presented with this is use virtualization, something like Docker. If you're not familiar with Docker, a quick background here. It's a program for creating virtual build environments. It creates these image files that Docker runs as containers. It comes with Debian 10 Buster, but it's also available as a download for earlier Debian releases. A Docker container is a virtual computing environment that gets run from an image file. Many containers can be run from the same Docker image. A Docker image file is all the binaries to define a virtual environment. And the image files get created by Docker files which spec out exactly what goes in and what sort of configuration has to happen there. Now, pre-built image files containing applications and operating systems are available for download on Docker Hub, or you can build your own. But the point is that Docker is fairly well proved out. It's available everywhere. And if you're running Buster or later, it's just an apt-get to install it. But it does require some level of effort. In my experience, Docker is more of a programming language than an application. It's incredibly powerful and very flexible, but it has a cost and ease of use. And this is fine if you're only using it to configure something once and you're done with it. However, I frequently want to do the same thing with slight variations. I need to build Debian packages, but I need to build them for a different operating system release. I need to build for an operating system release, but I need to use a different sources list to pull in development versions of packages or release versions of packages. Or, as the project lead for ONIE, I need to build something that doesn't remotely build for Debian, but I'd like it to be as easy as it is to build for Debian. So in order to get Docker to do this, I needed a tool that would allow settings of defaults for image creation and for runtime. There's a lot of typing in setting up a Docker file to create an image file. There's a lot of typing to get a Docker file to run and be convenient to use at the same time. This is especially true if you happen to need to be in the Docker file. If it's a build environment where you're debugging something, you're going to be spending a lot of time in there. It would be nice if it was comfortable. So the point is, all of this can be done without wrapping Docker, but it's a lot of typing, it's a lot of edge cases, it's a lot of things that are mostly one-offs for people, and really nobody's going to want to do that unless you're somebody like me who's dealing with it constantly. Then the investment in getting that one thing right pays off. So right now I'd like to do a quick demonstration just to show you what this looks like. I'll build package watchdog for Debian 10 Buster from an Ubuntu 18 system. This will illustrate the build workflow, how we create an image to then run as a container, some of the container runtime features, and the aspects of building inside the container and using it as a debug environment. It does not demonstrate a whole bunch of other things that does that are basically clever Docker tricks that I figured out at one point and wrote down to make easy. It's got automation features so you can run a command in the container without having to log into it. There's commands for managing containers, adding, deleting, observing, and a bunch of other nice-to-have features like being able to log into a running container without a whole lot of typing. Whole bunch of stuff. It's in the man pages and the documentation, but it's beyond the scope of this talk. So if we take a look at my demo system here, you can see that it's an Ubuntu system. And if I had to build a package for, say, Debian Buster, it'd be rather difficult. But fortunately, do will create a virtual environment for me. So, since I can't remember exactly how it does that, I take a look at the help for my installed copy of do. I see down here, oh, there's one for Debian 10. So I will just copy that example. And what it will do is now download a Debian 10 Docker image from Docker Hub. And then it will run a couple of modifications on that to add some nice-to-have features and create me a container. Okay, here we are a few minutes later. It's downloaded a bunch of packages and installed them and created my container. Now if I take a look at the command I'd originally run here, just to break this down, do takes the argument from Debian 10, that's the name of the base Docker image that it used to create its new Docker image off of. It provides a description of what the Docker container will look like, names it, sets a prompt within the Docker container so it's obvious that you're in a Docker container, or at least you have the chance of noticing that, and then tags the image, and then uses template Debian Package, which is part of do that tells it to configure itself to build Debian packages. So let me split into two windows here. So if I do So in one, I'll stay on my host system, and the other, I'll go into the container. So if I type do run, I had a Docker image already set up and configured here to build for Ubuntu, but it's giving me a choice of the one I want to run. So I want to build for Debian 10. And so let's take a quick look at what it just did here. So this wraps Docker commands. And what it's done here is set up a Docker container instance that is interactive, set up for a terminal. It will delete it when it's done. It's mounted my home directory here, which is incredibly useful. And it's also running this script called container create user, which creates an account for me within the container so I retain my user ID. So it's basically like I'm still on the same system. It tells me how many containers I'm currently running, lets me know that I've been created as a user ID, and now I'm logged in. So if I take a look at my directory in the container, that's all of what I've got on my home directory. If I take a look at my account on my demo system, we can see it's the same directory. So now that we've got the container running in the right pane, we can see that we're in a Buster environment. And the pane on the left continues to be the host system, which is still running Ubuntu. Now, to build a package like Watchdog, you may have to edit the apt sources list file to add Debian source entries. A lot of the containers that you'll pull out of Docker Hub do not seem to have this. But I've edited that off screen to add the deb source entries. So if we get the source for Watchdog, okay, you can see it's pulled from the Debian Buster repository there. And we'll get the apt sources build dependencies for that. So we're in the Watchdog directory. Let's build. And this will take a minute, so I'm going to jump cut. Now if we take a look at our build area, as is typical with Debian package builds, it puts the debs one level up. And there we can see we have a deb. Now what's nice about this, because it's due, is that on the host, we also have the same deb because it mounted the user's home directory. And to exit the container, all I have to do is type exit. And you can see from the prompt change that I'm back on the Ubuntu host. So that was building Watchdog for a different Debian distribution. Let's take a closer look at what was going on in some of those steps where the Docker image was actually created. So our base image was a Debian Buster image. So that's most of the operating system right there. We added some do features that are common to all do containers that it expects to be there. Things like the script that creates the user in the container with the same user ID they have outside of the container, so that all files created by the container that are left behind on the host are owned by them. We add some stuff to configure it in its role as a Debian package build container. And then we use the do runtime app to define the image we're going to create and actually run it and supply a bunch of defaults to make that easier. However, we can take this a step further. Building Debian packages is still pretty familiar. Let's head a little bit more out to the extremes and build something that isn't Debianized, doesn't build a package, and won't even run on Debian. This is where I get back to my role as project lead for ONIE, which is firmware that runs on network switches. So from this, let's see how this is going to work. So we start with our base Docker image, which is stretch, and we add a bunch of do features. Now, I'd mentioned this previously. Let's take a closer look at what they look like. So when you check out the source code, you'll see the directory called Common Templates, which has a Dockerfile config and a Dockerfile template. Both of these work together to create the Dockerfile that ultimately creates the image. One of them supplies some hints about what the container should be called. how it should be run. It can give some hints about mounting directories. For example, the Debian Package build container will advise it if you happen to be running it in an automated mode where it will just build out of the current directory to mount the directory above the current directory so that any debs that are created are not part of the container but are part of the host file system and don't vanish when the container does. I wouldn't have been stupid enough to get burned on this the first time, but it seems like a useful feature. The next thing down there is the file system directory, which is a one-to-one mapping of what will get copied into the container. So it's very easy if you want to get a file to a particular location, just specify the path under file system and do will put it there when it creates it. A couple of things we have here under etc. Custom login messages, so you can be aware of what kind of container you're actually running when you log into it. It modifies the bash RC to be able to set the prompt so that when you're in a container, you'll have an idea that you're actually in a container. Because it mounts the host file system, it can get kind of confusing as to where you actually are because everything kind of looks the same. Further on down under user local bin, we've got the container create user script, which allows you to become the user in the container, or if you're invoking it from outside, run commands in the container like it's actually you there. Very handy if you need access to things like config files or SSH keys, etc. And then there's another script in there which I won't touch on too much called do build, which is a default build script. Do will invoke this. There's a command for do to invoke this, and it will do whatever the thing needs to build. So if you have a default install case and you hate typing, you can have this script just build things. The one for Debian packaging does an apt-get update, upgrade, installs all the dependencies, runs dpackage build package, and then quits. So very easy. It takes the 3 steps that Debian's already got and turns them into 1. Apart from that, there's the install common config lib template. This is common utility for copying files around, setting up the container, things like that. Again, common to all do builds. And 2 install config templates, pre and post install. Pre is the first thing that runs in an unmodified container, and post runs at the end of it. So once that gets installed, we move on to the particulars of what we're trying to build a container for. In this case, the ONIE build. Now, I've mentioned previously Debian Package. There's really not a whole lot that gets added there. ONIE, on the other hand, is a little more interesting. So we have the Docker file config. It has different suggestions about mounting directories when it gets run by the do application. A couple of other things there. Of interest here in the sources list, there's a stretch backports because the ONIE build environment requires some packages from stretch backports. So that was sort of an interesting example of how you can enhance the container. And then the bash RC just changes the prompt to be ONIE, so it's clear that you're in that environment. The default build script builds one of 200 possible targets. I'm not sure that it's entirely useful there, but for consistency and the purposes of providing a way for a new user to just get something up and running quickly to get an understanding of things, I thought it was useful. And then there's the post-install config template, which is where things really get interesting, because in this file, apart from doing the regular install of packages and such, it also has to pull down a couple of packages from GitHub, install them, and one of them it has to actually build. So to set up a more complex build environment, this would be a good example of that. Now, I had a demo all planned out, but in looking at the amount of time I've got left, I pretty much had to cut that. However, having demonstrated package build, it pretty much follows the same concepts. So, in conclusion, do I think is a great way to simplify building code that isn't Debianized. The build environment only has to be defined once. Like I said, I'm currently working on getting do into Debian so that everybody can get a hold of this, and ideally, maybe create some additional configurations for it to build for various open source projects. We'll see how that goes. Maybe it takes off, maybe it doesn't, but it's never going anywhere unless it's completely available to everybody. Do is written in Bash, so it's really easy to modify and understand. I wanted a low bar to entry for this project, so people who are trying to set up build environments or just use it could do so with a minimal amount of difficulty. I know we're not all proficient in Perl or Python, but I'm sure all of us speak at least some level of tourist Bash where the commands we're typing look something like the commands do is actually running. And I would say if you're working on a project that has a complex build environment, I think do can dramatically simplify deploying that environment and helping other people working on the project get their environment set up. So I'll open this up for any questions and say thank you, everybody.
All right. Thanks for the talk, Alex. Very interesting. We don't have, we're a little bit short on time, so we're going to have 2 questions. But if people have more questions, they can ask on Etherpad, and we'll be able to answer. So the first one is, when will it be in Debian?
So hopefully in the near future. Garrett and I are working on it. So hopefully within a couple of weeks or so. I got delayed with a massive project at work, but now I've got more time to sink into this, so I'm hoping it'll pan out pretty well. And I see there was a second question here within Etherpad. So it's available. So coming up soon. There's a question about comparing it with SBuild. The scope of do is a little bit bigger than SBuild, although it emulates some of the functionality. But a head-to-head comparison would be a good idea to distinguish the differences. Can you build for different architectures? Yes, there's a feature in there. If you download a container based on a different architecture, it will use QEMU to run it. So you build an emulation. It's not a true cross-compile. But if you need something quick, that should work. And is it available for other architectures? Right now, it's got a bunch of stuff around package install and apt that's sort of hard-coded for Debian distributions. But there's nothing in there that would prevent it apart from time and effort.
Well, thanks a lot. Sadly, that's all the time we have. But as I said, if you have more questions, I'm sure they can reach you.
Absolutely. All right. Thank you.